Well, thank you for taking the time. Welcome to today's session. I'm Sam DeBow, part of the VMware team focused on our Tanzu application platform, which effectively means how can we help developers be productive on top of Kubernetes. And joining me today?
Hey everybody, I'm Andrew Scorstone. Today I'm going to be talking about Tanzu for Kubernetes operations at a high level, and then I'm going to be going a little bit deeper into Tanzu mission control. I'll be talking specifically about some exciting capabilities that we've added for lifecycle management around EKS.
Hello, everybody. My name is Ryan Baker. I am a technical marketer turned product manager as of last Monday. So new exciting changes. But yeah, I'll be up talking about the Tanzu application platform. That's what I've worked on since my entire time at VMware. So I'm excited to be up here. I'll get to do a demo and kind of walk you through what it looks like from a developer experience as well from an operator experience. So kick it back to you, Sam.
Perfect. So we'll start with just kind of laying some of the groundworks around kind of modern application platform and where VMware is in its journey and what we're hearing from customers. As Ryan and Andrew said, we'll definitely save some time for a demo and Q&A as well. Before we jump in, how many of you are familiar with Tanzu, VMware Tanzu? Okay, we've got a good show of hands, some perhaps where this is new. So we'll level set as well just around the portfolio and how we've kind of built on kind of years of innovation, particularly from Pivotal, which was acquired by VMware or backed by VMware a few years ago. So I want to orientate first of all around this idea of digital smart and why is this relevant? Well, when we speak with customers, there's kind of two kind of compounding outcomes that we hear from them. One is how can they accelerate innovation within their organization? And the second one is how can they increase user satisfaction? And the core premise of this is really driven by the applications and the application development teams leveraging this. And while this in theory sounds easy, if you think about how much the landscape has changed, AWS I believe is 16 years old, Kubernetes introduced 2014, 2015, and so much has changed during that time. You think about all the announcements today. And as applications have been built, and this race to digital smart, if you're on finance and fintech, you're thinking about how can we leverage open banking and build some of those APIs to leverage those services. Or if you're in manufacturing, how can you have app-driven production lines that in the morning you're building 10-inch mobile phone screens, and in the afternoon you're building a monitor for an EV vehicle and a new fleet. And so what we're seeing is this idea of automation. How can we make sure applications are the forefront of driving that? And as I said, there's challenges with this, languages, frameworks, services. How many services were announced by AWS just today? How many of you got an email saying, we need to go check out what that is? How do we think about that in our application development? And so it's important that we think about these early on. However, what's happening as we speak to customers is there's a series of kind of challenges and patterns that we're seeing. One is, as kind of a result of this, there's expectation as Kubernetes becomes the new IaaS, or the default IaaS, for your developers to be Kubernetes experts. And the reality is Kubernetes was never designed to be a developer interface. It was designed to help empower development, but not be a developer interface. At the same time, there's not a single conversation that I'm in where security isn't top of mind. We see software supply chain attacks on the rise, open source vulnerabilities. How do you think about detaching that single application away from that single supply chain and look at security across the board? And at the same time, our VMware survey that we sent out to our customers shows that at least 30% of our customers have more than 50 clusters in production. How many of you are in an organization that have more than 50 clusters in production right now? Okay. How many have more than 10? So even at that scale, when you start to think about your Kubernetes fleet, you're deploying, provisioning, managing, how do you embed some of those governance and controls into your Kubernetes fleet? And so Andrew will go into a bit more about that later on today. So this idea of the platform team, and I'll speak to this slide in a second, that we're seeing kind of rise. And these platform teams are built from kind of cross-functional subject matter experts. They're engineers, they're security teams, DevOps experts, specific cloud expertise. And they're forming together with the idea of building a product. And this product is an internal product which is given to the development teams, and primarily developers as the consumer of that product. And they're forming together to try and address some of these common challenges. And that's really where the heart of VMware Tanzu has been built. It's been built to help platform teams thrive and build modern applications. Starting on the left here are VMware Tanzu for Kubernetes operations. focused on how can you manage your fleet of Kubernetes, ensure compliance is baked in, make sure you have the governance controls and automation across Kubernetes. And once you have that and you've got good control over your clusters, how do you think about the applications and your application processes and the tools that you're using to build and innovate on top of that as well? And that's where we provide Tanzu Application Platform as a consistent developer experience. And technology, just for technology's sake, isn't really the best outcome. What you've got to start thinking about the people, processes, and of course, the best practices you can have. And that's where our Tanzu Labs comes in, has had great success over the years with customers. So we're going to jump into the Tanzu Application Platform. Before I do that, there's a few attributes here I want to touch on in terms of what is an application platform. I'm personally of the belief, particularly when I speak with customers, that nearly every single one of you in this room might have some level of application platform. You might think about it more as an application stack. Perhaps it's some scripts that's IaaS scripts building provisioning infrastructure that you see as for your developers. Perhaps there's a security scanning tool that you're using. But ultimately, there's kind of these three core concepts that we orientate around the application platform. One is, how can you make sure your developers can be sufficient? Self-serve. How can they have the tools they need without having to customize the environment they're using? How can they have some freedom while ensuring that your operations team feels secure with the types of tooling that are being used? Shift left security. I'm sure you've all heard this by now 100 times. What does shift left actually mean? So we have this notion of thinking about security at runtime, security from the container image, but really security from shift left is all the way to that first line of code being written in the IDE. And how can we make sure security is being baked in from the second that your developers are writing their first line of code? And finally, technology evolves, right? You need an application platform that can be adjusted, adaptable, flexible, and abstracts the underlying infrastructure away from the desired outcomes that you have. So as I said, Tanzu Application Platform allows you to build rapid and secure paths to production. I'm going to orientate around this idea of inner loop and outer loop. Inner loop, which you'll see in the green here, is focused on making sure developers can be productive. They're able to learn, discover, and start. Leverage templates out of the box to build applications. Templates that your organization have approved, used, and you know there is a dedicated pattern for them to move forward and move fast. At the same time, they're able to discover APIs and make sure the APIs that you need to build those applications are available all within one place. Moving to the outer loop, which is in the blue here, this is focused on the security and the operations teams. How can you make sure your security teams are able to see vulnerabilities before they get to production? How can they have a dashboard, for example, that shows you the critical vulnerabilities? And you're able to enforce policies to say, we will not let anything go through if it's critical or high vulnerability. And that will make sure no code is actually pushed. And the key thing here is you're going to have one supply chain with multiple applications going to it. And that empowers your operations teams to make sure there's a consistent path to production, a secure path to production with common tooling. And so we're going to dive a bit more into what is Tanzu Application Platform. And in short, it helps unlock developer productivity, build rapid, secure pipelines to production, and helps coordinate the work of platform teams. And to jump into a demo shortly, I'm going to hand to Ryan Baker.
Great, thank you, Sam. All right, so real quickly, Sam kind of gave a quick overview, but let's hop back into this slide, because this will really kind of help set the demo up. So Sam talked a little bit about the inner loop. So I'm going to, in a second here, I'm going to put my developer hat on. I'm going to walk you through exactly what it looks like to be a developer on the Tanzu Application Platform, demonstrate how we abstract you away from the complexity of Kubernetes so that you don't have to touch Kubernetes at all. After I walk through that, I'm going to show you exactly how we can start with those application accelerators that he talked about. I'm going to pull one down into my IDE. I'm going to set it up so that I can deploy my application out to Kubernetes and iterate on it and see immediate results as I start to change that code. Once I finish up the application, I'll walk you through the workload itself. So how do we create the workload in the Tanzu Application Platform? How do I show the progress as it goes through the supply chain in our backstage UI? How do I see exactly where it's at? How do I ensure that we're shifting left on security, see what vulnerabilities are there, making sure that it's getting stopped as part of that supply chain? All right, so stepping forward, I talked a lot about supply chains, but let's kind of review exactly what we're going to see. So moving into that outer loop, I'm going to walk you through exactly how it gets created. So we're going to create the workload, And as we create the workload, I'm going to walk you through exactly, we're going to test that. So we're going to do continuous integration tests with Tekton. So open source continuous integration that's part of the Cloud Native Foundation. After we do that, I'm going to scan the source code. I'm going to check the dependencies for any third-party, or sorry, all of the third-party dependencies for application for any vulnerabilities that may exist in that source code. This is where we really start to shift left on security, like where Sam talked about. We're ensuring that before your application ever makes it to production, we're going to scan it, ensure there aren't any vulnerabilities that exceed your organization's scan policy. And if we find vulnerabilities that exceed that scan policy, we'll stop it right there. The next step in the process is we're going to build a container image. And we're not going to use this using Docker files, because again, our purpose is to abstract developers, abstract operators away from the complexities of building modern applications, abstract them away from the complexity of Kubernetes. So we're going to use cloud native build packs in our Tanzu build service to analyze that source code, figure out what it is. We're going to compare the source code with known signatures for what it is. So if it's a Spring Boot application, and we see a pom.xml, we're going to know, hey, this is a Spring application. Then we're going to leverage those cloud native build packs, which are built and maintained by the open source community. So it's not your developers, it's not your operators that are maintaining the Docker file images. They're not ensuring that they're up with the latest best practices for the application or the vulnerabilities. You're actually leveraging the open source community for it and allowing your developers and operators to focus on building terrific applications and bug fixes and features and all the things that they want to do as developers. Once we do that, we'll push the image up to our container registry, and we will scan it using a Gripe image scanner. So we'll pull that image down, we'll scan it for vulnerabilities, again, making sure that we don't have any vulnerabilities that exceed our scan policy. And last but not least, and this is a really small box and it really should be bigger, but we're gonna deploy the configuration for Kubernetes. Well, how do we get that configuration for Kubernetes? We actually dynamically generate that configuration based off of the bill of materials that we build and establish when we go through that Tanzu build service. Because don't forget, we're using those cloud native build packs to analyze the source code, so we know exactly what that is. So a perfect example of this is that we can look at an application, and I'll use Spring Boot again. We know that it's a Spring Boot application by the existence of a pom.xml. We know if you're using the Spring Boot actuators, it's going to create health endpoints, so you can tell the health of the application. And it's going to put them at specific paths for health readiness and liveness probes. So we're able to dynamically generate that Kubernetes configuration for you and apply that to a Kubernetes cluster. Again, ensuring that your developers and operators don't have to worry about it. I talked a lot about a lot of tools as I went through this, and this is just the out-of-the-box experience that we provide. With our out-of-box experience, we want to make sure that everybody that uses the platform can get started and can get started quickly. We don't want them to have to toil with a bunch of different tools. However, one of the core tenets of our application platform is to ensure that it's modular in nature. So if your supply chain isn't exactly this, you're able to add components, you're able to remove components to meet your organization's best practices to take an application from source code to a running application. So we can swap these out. If you have an existing investment in Snyk, for example, for vulnerability scanning, you're able to choose to use the Snyk vulnerability scanner rather than using the open source Gripe scanner. Maybe you have existing in AWS or existing investments in AWS tooling like code build. Able to swap those out as well. These supply chains are modular in nature. They're all stored as Kubernetes resources, so you're able to make them fit your organization's best practices. All right, I've talked enough to slides. Let's go ahead and hop over, and we're going to do a live demo. So if everybody can just kind of hope with me here that this works, if we can switch over. So I talked a little bit about application accelerators. I talked about how developers can get started by using an application accelerator, so they're not starting from scratch. So it can help drive consistency across your organization and applications. So these are the application accelerators that we provide out of box. These are in no way intended to be the ones that your organization use. They're just starter templates that you can look at, build your own model off of. And again, these are ones that we see our software architects, operations teams, security teams, those type of teams, looking at combining, working together to build a template that you can use for your organization to give a good starting point for an application. So let's just go ahead and do a simple Hello World Tanzu Java Web UI. And I'm going to go in here. You can see as I select this accelerator, you have a lot of different options. And what's actually going to happen here is I'm going to fiddle with these options, and exactly as a developer, I'm going to configure it exactly how I want my application as a starting point. So on this one, I'm just going to uncheck a lot of these required stuff just to save some time. And I'm going to go ahead and do next. And what's going to happen in the background here is it's going to dynamically generate all of that configuration together, and it's going to give me a zip file that I can download. Now, that zip file will contain our application source code to get started with, but it's also going to contain a workload.yaml. This workload.yaml is the only YAML that you will have to interface with as a developer, as an operator, in order to get the application up and running on Kubernetes. So if we look at this one specifically, I think it's 23 lines of code. Yeah, so 23 lines of code. So if you are familiar with deploying an application on Kubernetes, you know that it's going to take hundreds, if not thousands, of lines of YAML in order to define all of the parameters that it's going to require to take to get your application out and running on production. Now, the other thing that I like to point out here is not necessarily the existence of a file, but the lack of a file. And that file that we're missing is a Docker file, right? I just talked about that earlier, about how we can build container images without using a Docker file. We're going to inspect that source code. We're going to build that container image for you without having to worry about it. All right, so now typically what I would do here is I would go ahead and download the zip file, but I already have it pushed across. So let's go ahead and open my IDE, and I'm going to show you how we pull this application accelerator down and we start to develop and we start to iterate on our application. So I'm in Visual Studio Code. I've pulled this application accelerator down. And what I've done, just to save a little bit of time, is I've already launched my application. But essentially, all I had to do here was do a Tanzu live update start. And what this did was it inspected my source code, built a container image, generated the Kubernetes configuration for me, and deployed it out to a Kubernetes cluster. And in this case, it's EKS running in the cloud. And from there, I'm able to rapidly iterate on my application. So let's take a look at what this is actually doing. So if I hop back up, and let's just make a simple code change here. So we're going to change my index.html to, let's just call it reinvent. And what I'm going to do is I'm going to save this, and you're going to see it start to trigger. And what it's doing is it's detecting that I have changed my application code, and it's rebuilding my application and injecting that new built application into my container image. So if I flip over to my running application here, we are going to see that this is what it was before. And if I just do a simple refresh, we're going to see that my code is updated. And now it's going to show that it's updated with my latest code. So in the background, it's constantly updating my Kubernetes cluster. So let's pause and let's think about this. There's two things that I like to think about from this standpoint. The first thing is that this is happening in a Kubernetes cluster in the cloud, right? And what's one thing that developers all want to do? They want to build applications on their laptop, which is great until your application requires a monster laptop that they have to carry around, very expensive asset, right? So by able to launch it in the cloud, we're able to take advantages of things like dynamic scaling, right? If a developer's not working, scale that cluster back down, save some money that way. The other big thing that I like to think about is, as a previous DevOps engineer, I used to beat my head against the desk all the time when a developer brought me an application and said, hey, it's ready to go. And then I would try to deploy it out on top of Kubernetes, and nothing would work. And it wouldn't work because they were building that application on their laptop, either natively on their laptop or using something like Docker Compose, which does not resemble production environment at all, right? So there's always then a ton of back and forth that's going on between the developer and the operator trying to get the application up and running in Kubernetes. By deploying directly to a Kubernetes cluster with Tanzu application platform on it, you are minimizing the differences between your development and your production environment. So you can remove a lot of that complexity that's happening and a lot of the back and forth that can occur between your developers and operators. All right, so I finished building my application. My developer says, hey, I'm done. Let's go ahead and create that workload. So again, because of time, I've gone ahead and created the workload for us automatically. But what we can do is we can actually hop out here. And this is our, again, our Backstage-based UI. And we've built some plugins to integrate in so that you can actually see the progress through the supply chain as it goes through. So what you can see here is I've taken that application code and I have supplied it to the Tanzu application platform with just a simple CLI command. It was simple as Tanzu app workload create, and then I pointed it towards that config.workload file, that config.workload.yaml file that I showed earlier. And what it's done is it's actually consumed that workload.yaml and mapped it to a supply chain. And let me zoom this in here real quick so we can see a little bit better. But you can see it's gone through those steps that I talked about earlier. So we established the source code provider. From there, we actually tested the source code. So we used the Tekton tooling to, oh man, let's refresh again. So we used the Tekton tooling to, gosh darn, it's not letting me scroll. There we go. So we used the Tecton tooling to run a continuous integration test that was built into our code. So we can see that we executed 2 tests. Both of them passed. There were no failures. So we went ahead and continued on to the next step in our supply chain. And let's hop back up here. Sorry, this zooming has really messed me up. All right, so the next step in the supply chain is to pull down the source code and inspect the source code for any vulnerabilities. And you can see that we did find one critical vulnerability. And typically, this would be against my organization's scan policy, right? We don't want any significant vulnerabilities making it through to production. So let's take a look at my scan policy here and see exactly why this one's getting through. So you can see as part of my scan policy, I have established that I'm not going to allow any severities that are critical and high in nature, right? Don't want to leave those through. But any part of a scan policy and a vulnerability remediation is to triage that vulnerability and make sure that it's actually applicable. And here we have identified that this was a false positive, right? Pretty common with vulnerability scanners to get false positives. So we've added it as an ignored CVE, so it went ahead and allowed it to work through the supply chain. So let's work through the next step on it. And this step is our image provider. So this is where we're actually using the Tanzu build service to build that container image. So if we hop down into this one, we can see exactly what it's doing. We can see that it is pulling down the source code here. So it's going to pull down the source code, and it's going to use these cloud-native build packs. And this is where I really like to focus in on, because here we can see that it is using, 11 out of 25 build packs that are participating. So each one of those build packs has a signature in it that is compared against the source code. And if it matches that signature, it's going to say, hey, I'm going to use that cloud-native build pack in order to build my application. At the very end, it's going to take all of the layers that those cloud-native build packs have created. It's going to assemble it up to a container image and push it up into our container registry. All right, so next step, here's where we are showcasing some of our integration capabilities. You can see in tiny, tiny little font here that we are using the Sneak vulnerability scanner. So this is an integration point that I set up, so we're actually using Sneak rather than Gripe. So as we go through this, we can see that we have scanned our container for images. We have no violations of our policy. And the most we have is a medium severity vulnerability. So we're going to go ahead and allow that application to go ahead and continue through. Then finally, after that's passed, it goes through a whole bunch of steps here. And these steps are where we actually look at that bill of materials that we built and attached to the container image in that build service step. And we're going to analyze it and figure out what type of application it is so we can dynamically build the Kubernetes configuration for you and deploy it out into your Kubernetes cluster. Another one that I really like to point out here is the service bindings. So we are at reInvent. So this is a really good point to mention that as part of that workload.yaml, you can actually bind your application to an existing service that's out there already. So if you have an RDS instance, or if you have a RabbitMQ instance, or something that you want to bind to add some statefulness to your application, you can specify that as part of a workload.yaml, and it will set up all of the connections in order to bind your application to it and create all the secrets for you. So that's walking through the supply chain. One of the things that I like to talk about is really how this differs from a pipeline, right? I've been very particular about calling this a supply chain and not a pipeline. So this introduces the concept of choreography rather than just orchestration. Think about if you have a new base OS container image. Typically with a pipeline, you have a single trigger, which is a code commit, right? So if you have a new base OS image, you want to pull that down, you've got to do either a code change to your application or just maybe like an empty commit just to trigger your pipeline. With our choreography, we're constantly watching and we're constantly reconciling in the background. So if you have a new base OS image that comes down as part of this image provider, it's going to automatically trigger at that image provider stage and continue to do every step in that supply chain that is dependent upon that image scan. So it'll automatically build the new image, and it'll push it all the way through out into production. All right, so before I hop back into slides, let me show one thing here that's kind of important and pretty neat from a security perspective. So we just introduced this in our latest release, and it's our security analysis dashboard. So this gives you a view into all of the workloads that you have created and whether or not they exceed or meet your security policy. So it gives you a quick view. When you have multiple applications, you can hop into here. You can see how many vulnerabilities you have of each criticality, but also which applications are deployed out into production that exceed your policy. So just a real quick, nice view of your security posture. All right, so let's go ahead and can we hop back to the slide deck? Cool, thank you. All right, so just to kind of summarize up. So I just talked about, Sam and I just talked and spent a lot of time about talking about the application layer up, right? So we talked about how we're unlocking developer productivity with EKS, abstracting them away from, with the Tanzu application platform on top of EKS, abstracting them away from the complexity of Kubernetes and all of the YAML required. I showed you how you can use rapid yet sustainable paths to production on AWS and EKS to get your applications deployed out into production. And finally, really talked and hit hard about how we can minimize the toil between your development and operations team. And all of this is on top of Amazon EKS. Everything I demoed right now is on top of EKS. So we're taking that platform and we're just giving you the nice layer of the application and the seamless integration for your developers. However, as we talked earlier, a lot of organizations have a lot of wrestling that they have to do when they start to scale a lot of Kubernetes platforms. And so with that, I think now's a good time to bring up Andrew and talk a little bit more about how we can leverage the Tanzu for Kubernetes operations to help wrangle in all of the Kubernetes clusters that you have to manage.
All right, Ryan. Thanks, Sam. Can you guys hear me okay? Because they changed out my mic like 4 times already. So. All right, so let's get into it. So Tanzu for Kubernetes operations is a collection of technologies designed to help solve the challenges of managing modern infrastructure at scale. So what does that mean? Well, it provides teams with the tooling and standards necessary to simplify, secure, and optimize their cloud-native fleets. So starting with simplify, TKO empowers developers with self-service access to the resources they need to build their applications, and also a consistent Kubernetes dial tone. TKO is built on and provides a lot of automation out of the box, and I'll be showing you more and more of this as I go through the slides and also do a demo. But it's built on and provides a ton of automation, because you really can't have self-service without this automation, right? For security, TKO provides the controls to help teams establish and enforce a consistent security posture across their distributed environments. As Sam mentioned, there's that goal to shift left. Well, TKO provides the tooling to actually make that happen. Lastly, for optimize, TKO includes the ability to centrally monitor and manage your distributed environments. It has powerful tooling to give you valuable insights and visibility into these distributed applications, and the ability to correlate application issues that you might be experiencing to bottlenecks that you're seeing within the infrastructure. And it gives you the ability to quickly act upon those insights and get quicker mean time to resolution. And lastly, it also gives you very valuable insight into resource utilization, because we want to maximize the investments that we've made in our infrastructure. So it gives you dynamic view into how you're utilizing your cloud resources, and also provides recommendations on how you might be able to save costs. So I've talked a little bit about what the benefits of TKO are. Now let's get into the architecture a bit. And before we get into the technical elements of TKO, why do we need all of these pieces anyway? We have a lot of different infrastructure domains on the screen up here. Well, I'll share a story. A few years ago, I was working for a telecom provider, and I was on a Tiger team, and we were tasked with building out a container as a service platform from scratch. And this was kind of the early-ish days of Kubernetes. This was pre-pandemic, so this was probably 2017, 2018. And it was mostly to meet development workloads in kind of internal customers, internal development environments. But as we started to scale, and we started to bring on more internal tenants, we quickly realized that we needed a lot more than just a Kubernetes distribution a monitoring platform, a container registry. It got very complex very quickly as we began to scale, and we brought on more customers. So TKO, if you look across all of these different domains, we believe that it's a batteries included solution for running your cloud native environments, meaning VMware provides all of the tooling necessary to run and optimize these distributed systems. And one of the beautiful things about this architecture is that it is batteries included. We think it gives you everything you need, but it's also modular and pluggable, meaning you can pick and choose the areas where you want to optimize or you may need to optimize, but you can also just as easily continue to leverage existing investments that you've made. So it's pretty powerful in that regard. So starting at the bottom, TKO includes a CNCF conformant, upstream compliant Kubernetes distribution in Tanzu Kubernetes Grid. TKG is designed from the ground up to run as well in your on-prem vSphere environment as it is in the cloud, and also in a hybrid scenario, so VMC on AWS as an example. It's digitally signed and secured by VMware. For monitoring, TKO seamlessly integrates with open source projects Prometheus and Grafana out of the gate. For connectivity, TKO includes a robust ingress controller and global load balancer in the NSX Advanced Load Balancer backed by Avi. For container networking, both Ontria and Calico CNIs are supported out of the gate. Sam and Ryan both talked about the supply chain, and we know it's under attack, and we hear more and more stories about that every day. TKO includes a secure and consistent container registry in Harbor. And we digitally sign all of the assets within the registry. And all of those images are guaranteed to be secure and maintained. And that coupled with, we also have a very robust policy engine within TMC, which I'll talk about here in a minute as well. So those secure images coupled with image registry policies powered by TMC helps ensure that the images that you're using to run your production applications are both secure and consistent. For observability, TKO includes ARIA operations for applications, formerly Tanzu Observability, backed by Wavefront. And this is an incredibly powerful tool. It's able to ingest literally millions of data points per second. It uses a technology called histograms, and that provides the ability to group logs, metrics, and traces, giving you literally a 1-second snapshot. You can even configure it at the sub-second level of what's happening within your infrastructure across all of the different domains that are involved in a modern infrastructure. So you're getting insights from your applications, from the infrastructure, from your cloud endpoints. And what it quickly enables you to do is identify what normal looks like for your environment. It quickly establishes what the baseline behavior in the environment is. And with that, it's able to quickly identify anomalies. Lastly, I saw an interesting bit on the internet recently. It was a survey published by Akamai that nearly 90% of internet traffic is API traffic. So we know we need to secure those APIs. TKO includes Tanzu Service Mesh, which is an incredibly powerful service mesh offering. It provides dynamic service discovery, and it provides the ability to encrypt the traffic between your microservices So it provides mutual TLS capabilities out of the box. And it also enables you to scale your applications up and down dynamically based on business and application demand. So incredibly powerful. Lastly, at the top, we have Tanzu Mission Control, which is really that unified hub, that unified control plane for managing your cloud-native infrastructure. And I'll go deeper into TMC, but it provides a lot of powerful capabilities related to lifecycle management, identity and access, network compliance and audit, and also data protection. Tanzu Mission Control empowers platform operators with the guardrails they need to establish better control and consistency across their cloud-native fleets. This gives developers self-service access to the resources they need with reduced friction and with reduced cognitive load of having to understand the nuances of the technology, as Sam and Ryan both mentioned. They don't need to be experts in Kubernetes. And what's really unique about TMC is it comes with a very flexible hierarchy and also a robust policy engine. And you can kind of liken this to Active Directory for cloud-native applications. So you can apply policies at different levels of the stack, and we have a couple of key abstractions within TMC that are offered to give you this flexibility. We have workspaces, which enable you to group namespaces across multiple clusters, across multiple clouds. Also, cluster groups, which gives you the same capability across clusters. So with that, you're able to organize your infrastructure and cloud-native workloads very flexibly. So for example, you can organize by geography, by business unit, by application, and apply policy accordingly. So it gives you a lot of flexibility. Getting into the core capabilities of TMC itself, starting kind of in the bottom left here, identity and access management. That's powered by the Pinniped open source project, and it provides team with the ability to bring their own identity provider and federate with TMC. So whether you're leveraging Active Directory or another LDAP solution, you can plug that into TMC very easily, federate, and then use that IDP to create your roles, create your role bindings, manage your role-based access control architecture, et cetera. For data protection, we've made a lot of investments in this area. That's powered by the Valero open source project, and it provides the ability to back up entire clusters, specific namespaces. You can exclude namespaces. On the restore side, you can restore within the same cluster. You can restore across clusters or even across clouds or distributions, so incredibly powerful. For security and compliance, you get very robust security policy capabilities included within TMC. You have the ability, and we provide templates to enforce either baseline security policies for, say, your dev workloads or more strict security policies for staging and production. So that gives you a ton of flexibility, again, leveraging that resource hierarchy with workspaces and cluster groups. And also, TMC provides the ability to perform inspections directly from the platform. You can do CIS benchmark testing, conformance testing, light inspections directly from the platform. So if you need to, say you have auditors on site or something like that, you can run a quick inspection and show that you're compliant. For the unified policy engine, I talked about access and security. In addition to those, we provide policies for network, quota, and image registry. And those are kind of the 5 that we hear most of our customers asking for. Additionally, To provide even more flexibility, we have an integration with the Gatekeeper project by Open Policy Agent, and you can create custom policies. It gives you a ton of flexibility there as well. For lifecycle management, from TMC's inception, you've been able to provision and lifecycle manage TKG clusters directly from the platform. And that's leveraging the CABI project, the Cluster API open source project. And then just recently, I'm excited to announce, in our continued engineering partnership with AWS, we've also added support for lifecycle management of EKS clusters natively from the platform. So what that means is you can now use TMC to provision, to create, update, upgrade, scale, and delete EKS clusters natively from TMC via the UI, CLI, or API. For baseline diagnostics, I'll show you this in the demo, but you get insights into your clusters directly from the platform. You get CPU and RAM utilization. You also get the health of different agents and extensions that are running on your system. So it gives you very powerful insights right out of the box on the health of your cluster and different packages that are installed within it. For configuration management, to enable teams to continue to follow infrastructure as code and configuration management best practices, you can run your cluster configurations via your GitOps pipeline. We announced back in July, we have integration with the Flex CD project. We also have a very powerful Terraform provider. So you can continue to really just leverage the automation that you're already using and build that into your TMC management. There are a couple different methods of bringing clusters under TMC management. As I mentioned before, you can provision and lifecycle manage both TKG and now EKS clusters natively from the platform. You can also attach any CNCF conformant cluster to TMC. Either method that you utilize, you get those same benefits, those same streamlined day two operations that I mentioned before. So you get increased security, better visibility, better resource utilization, and cost optimization. So the outcome really is more streamlined and more consistent deployments. All right, before I get into the demo, I just wanted to talk a little bit about what I'm going to be showing you, what's kind of going on behind the scenes with the EKS lifecycle management architecture. Starting at the top left, the first thing that I'm going to be showing you is the creation of a dedicated EKS credential. And the engineering team did a great job of putting this together. It's an automated process that leverages a CloudFormation stack. And that provides TMC with the roles and permissions necessary to perform EKS lifecycle management on a customer's behalf. Once that credential is in place, I'm going to be showing you the creation of a cluster. And that's a pretty seamless process as well. Once that cluster is deployed, it's going to be part of a cluster group. I mentioned the resource hierarchy before. So it's going to be able to take advantage of all the centralized management capabilities within TMC, centralized policy, centralized access, the GitOps integration, et cetera. And then, of course, these are EKS clusters. They're leveraging the EKS APIs. So once they're provisioned running in AWS, you can take advantage of all of the latest and greatest services that AWS has to offer. Last slide before the demo. TMC uses an assumed role to provision clusters and node groups. I talked a little bit about the credential creation process before, and I'll show you this in the demo as well, but when you create that credential, and it'll create that assumed role as part of the CloudFormation stack, we're going to take the ARN, the Amazon resource number, and pass that back to TMC. When that happens, a couple of Lambda functions are spun up, specifically a data sync and a resource retriever Lambda. And these functions are invoked periodically to help facilitate communication back and forth between TMC and EKS. Additionally, after the cluster creation, we spin up that first node group. At that point, another Lambda gets spun up, and this one just once. It's called the auto-attach Lambda, and that installs the TMC agent to all of the nodes within the node group. And with that, I'm going to get into the demo. All right, so the first thing I'm going to be showing you is the credential creation. And as I mentioned before, I'm kind of showing you what this looks like from a UI perspective, but everything I'm going to be showing you is also supported via CLI and API, and soon also the TMC Terraform provider. So we're creating the credential here. It generates a CloudFormation template. This can be applied via either the AWS CLI or the UI console. I'm using the CLI in this case. So this will kick off the creation of that CloudFormation stack in your account. And this whole process takes maybe 2 to 3 minutes. It's pretty quick. I pre-recorded it in this case. All right, so you can see the different policies and roles that get created. At this stage, I'm taking that role ARN, and I'm going to pass it back to TMC. That spins up those couple of Lambdas that I talked about before. And then the template is created. It takes about 15 minutes for that to become valid, so I won't make you guys sit through that. All right, now we're creating our first EKS cluster. Again, we're just leveraging the EKS APIs for this. Selecting a credential that I created previously, the Kubernetes version. I'm swapping over to the US West 2 region, the Oregon region, because I've pre-configured a VPC, a virtual private cloud, which is a prerequisite for EKS if you've provisioned EKS before. We provide a link to some great documentation that AWS provides to automate the VPC creation. It'll just provide an S3 URL to provide back to CloudFormation to spin that up. But I've pre-configured the VPC. All right, so now we're into the node group configuration. Call them node pools within TMC, but same basic concept. Incrementing up the number of nodes, and then that cluster creation process is underway. This all in takes about 10 to 15 minutes, just same as if you were provisioning natively. All right, so now that cluster is deployed. That is the create workflow. Now we're going to get into the update workflow. A lot of different things you can update. In this case, I'm just going to be showing a simple scale up. So we're adding one more node to that node pool, going from 3 to 4. All right, so now we're at 4 nodes within that node group. And this is the view of the main cluster screen. And as I was showing before, it provides some great details on some baseline diagnostics. You can see your CPU and RAM utilization and the health of different components and agents that are installed on the machine. All right, now we're going to be doing a Kubernetes upgrade. TMC does it a little bit different. We actually do an orchestrated upgrade. We're going to be upgrading the control plane first and then the node groups. And if you've upgraded EKS before, you know that it's kind of a rolling upgrade, so it will provision new nodes with that updated version and then move the pods over. So we kind of follow the same logic. All right, so now that cluster is up and running. We're upgraded to the latest version of Kubernetes. TMC also provides the ability to access the cluster directly from the platform. You can download the kubeconfig and access the cluster that way. And I'm using the TMC CLI now to interface with the cluster. All right, so now we're going to deploy our first workload to the cluster. In this case, I'm going to be deploying WordPress. And one thing I'll call out about this particular installation that's somewhat unique within TMC, if you've provisioned WordPress before, it creates a couple of pods. You have the front-end UI pod, and then you also have the back-end database. I'm leveraging Bitnami Helm to do this installation, and that deploys a MariaDB pod. And that, of course, is stateful, and it requires a persistent volume. We're including the AWS EBS CSI driver natively in the installation. So that's one less step you'll have to take in doing a stateful workload deployment. All right, so there's our 2 pods. And then you can see that the persistent volumes were created as well. So that application is now up and running. Talked a little bit about configuration management before. TMC also provides a pretty robust package management solution. This is powered by Carvel. And it enables you to install packages directly from the platform. So in this case, I'm going to be installing Prometheus, the bits for Prometheus. And if you use the TMC catalog, we're going to do some of the heavy lifting for you. So you install the bits for Prometheus, and when updates become available, that'll all happen automatically on the back end. So all of the updates and lifecycle management of those packages will happen automatically. All right, I talked a little bit about the inspections before. So this is an example of running a quick, light inspection directly from the platform. Really powerful for your security and compliance. There's also conformance testing that you can run just to ensure that Kubernetes best practices are being followed. All right, now we're going to get into the data protection element. So that WordPress namespace that we created before to support that application deployment. Selecting an S3 target. And performing that backup. This is a pretty quick and seamless process. The backup itself takes 40 seconds, 45 seconds. And now we're going to jump over to a different cluster to perform the restore. So this is a cluster I created previously. Has visibility into that WordPress backup that we performed before. and then performing that restore across clusters. And the last thing I want to show you is the policy engine, which I've mentioned a couple of times. So we can access that directly from the cluster view. So as I mentioned before, kind of like Active Directory for cloud-native apps. When you're applying policies within TMC, you can do it really at any level of this stack. So in this case, we're looking at that CNA environment. That is the TMC organization that I'm currently logged into. That's the organization for cloud-native applications. So you can apply security policies, for example, at that level, and those policies will get propagated down and inherited by every object underneath it. You can also override policies really at any level of the stack, so within the cluster group or specific clusters. Again, in talking to customers, there are 5 key areas where we built this policy engine based off of. So we have security policies, image registry, network, quota, and then also the custom policies powered by OPA Gatekeeper. And that's really all I wanted to show you guys today. So thank you so much.